All right, we're going to take a look at section 3.5, division of whole numbers. So we're going to take a look. We've just finished multiplication, and now we're going to take a look at what we mean by division. And division is simply repeated subtraction. We can also, as the students get older, definition is to multiply by the reciprocal. And we'll talk about that more when we get into fractions or rational numbers. And we can look at it as A divided by B will always produce a number C if and only if B times C equals A. And we'll talk a little bit about that a little bit further. So let's take a look at some vocab that is important for the students to understand. If we have a fraction, A divided by B equals C. This A value is what we call the dividend. So what's being divided? The B is doing all the work, it's the divisor, and the answer that we get with division is what we call the quotient. And this is true. We think about cross multiplying, or we think about the definition, we can always cross multiply B times C to get our answer A, which is right here. In elementary school, we might see it written this way. The divisor is on the outside, the dividend is on the inside, and our answer, our quotient, is up above. So here's your divisor again. Here's your dividend, what's being divided. And our answer is our quotient. And sometimes we have a remainder and sometimes we don't. And we'll talk about that as well in just a little bit. So let's look at ways or models or algorithms to show divisions. Models to show division of whole numbers. So the first one, I'm just going to look at the definition. I'm going to take a look at what we mean by repeated subtraction. And I just want to make sure it was recording. So this first one, repeated subtraction. And I'm not going to use large numbers because we're looking at concept here. So let's say we have 12 divided by 3. The idea is how many times can 3 be subtracted from 12? And so we can model this horizontally. I'm going to model it 2 different ways. First, if I start with 12 and we subtract 3, we get an answer of 9. Well, 9 is larger than 3, so we can do it again. We can subtract 3 again. Oops, sorry about that. It bled a little bit. And we get 6. We still can subtract 3. So if I subtract, I may have to switch pens here. Try this. If we subtract 3 again, we end up with 3. And if I subtract 3 again, we now end up with nothing. So how many times did we subtract 3? We repeated that process 4 times. And so therefore, 12 divided by 3 equals 4. Because we subtracted this 4 times. Okay, this pen is not going to work. Sorry about that. I will switch colors, see if another one will work better. All right. Now, if you don't like working across, we can do the same thing, but we can organize it as a tree. So I'm going to do the same problem, but I'm going to organize it visually a little bit different. So same example, 12 divided by 3, organized as a tree. So if I start with 12 and I subtract 3, I can say, well, that gives me 9. And again, I haven't gotten to 0 yet, and I can still subtract 3. So that's going to give me 6. I can subtract 3 again. That's going to give me 3. I can subtract 3 one more time, and I end up building this tree or staircase going down. And then we'll notice we ended up subtracting 3 4 times. And so once again, 12 divided by 3 is 4. Okay, so 3 was able to be subtracted 4 times. Second method we're going to take a look at is what we mean by a set model. So I'm going to do it smaller this time so we don't have quite as many elements to put into our sets. So let's model 6 divided by 3 and see what we end up with. So this means we're starting with 6 elements in our set. All right, so our set contains, and I'm going to do it this way, 1, 2, 3, 4, 5, 6. So say, for example, you had 6 cookies that you want to share with 3 friends. Okay. If there are 6 cookies to be shared with 3 friends, how many cookies will each friend receive? So if I take my set that has 6 cookies in it, and I know I have 3 friends, so here's friend number 1, here's friend number 2, and here's friend number 3, we can take and we can sort of subdivide these cookies into little groups, and we can say, well, it looks like I can put 2 of these cookies for the first friend, I can give 2 of these cookies for the second friend, and I can give 2 of these cookies to the third friend with none left over. So therefore, 6 cookies divided by 3 friends gives you 2 cookies each. Okay, so I didn't want to use a larger one because then we would have been putting a whole lot of dots or X's. These didn't come up too dark, but I put 2 cookies into each friend set. All right. So as you're writing, it's going to take me a minute to erase all this. And we will take a look at a few more models. Now, right now we're working with base 10. I'd like to start with what we are familiar with. And you'll be teaching base 10 to your elementary school students. So we're first going to look at the various methods. So now let's take a look at a missing factor model. This is actually showing them, it's a precursor to some pre-algebra and some algebra. It's using the definition that we talked about at the beginning. So this is the definition of division. So if you recall, I'm going to set this up again, 12 divided by 3, and we know it equals 4. I'll show you in a moment. So if we look at what we wrote at the beginning, we said A divided by B always gives us the quotient of C, and that can always be rewritten if and only if B times C equals A. Okay. If you prefer, you can think of it as A over B. And you may remember we used to cross multiply, and we'll get there again. That's the same as saying B times C equals A. So if I now know that the A is 12 and the B is 3 and the C is 4, okay, well, I have the answer here, but if I have 12, let's do this. 12 divided by 3 equals C. I can write this as, by definition, 3 times C equals 12. So we could ask our students, 3 times what number equals 12? And hopefully they're going to see that, since they've already done multiplication, 3 times 4 equals 12. So therefore, our answer, 12 divided by 3, would give us a quotient of 4. So you can always rewrite division as a multiplication problem. You can undo dividing by multiplying because they are reciprocals of each other. Now, we can also look at kind of a standard model, division algorithm. This is what you and I probably remember doing. This is a division model, sort of the standard model. Because sometimes we end up with a remainder. So we already know that A is the same as B times C, where C is the quotient. So we can say that division is always B times the quotient plus R, where this could be a remainder. Sometimes we have a remainder of 0, so it goes in evenly. It's called a factor. Other times we end up with a remainder. So for example, I like to start with what we know. Let's start with 32 divided by 4. How many 4s can we subtract from 32? How many groups of 4? You and I know, because we know our multiplication tables, 32 divided by 4 is 8. And there's no remainder. If I write out the standard algorithm, 4 goes into 32 8 times. Remember, 8 times 4 is 32. We subtract, and notice we have no remainder. Okay, so 8 divides 32. 8 divides 32 with no remainder. So what does that mean? That means 8 is a factor of 32. Factors are the numbers that multiply to get the product. So 8 times 4 is 32. Okay. Now, what if we change this problem ever so slightly and we say, all right, now that we have the idea and we practiced this for several days, what happens if I take 32 and I divide it by 5? Well, we can do this a couple of ways. If we look at the model we were just talking about, we can say 5 goes into 32. Well, we know it goes in 6 times because 6 times 5 is 30. But now the leftover is 2 and 5 cannot go into 2. And so the first thing we talk about around 3rd grade is 2 is the remainder. So we can say remainder 2. And then usually in 4th grade, we start introducing fractions and we talk about what we can do with that remainder. Sometimes you'll see it just as a capital R. Okay. Now, if we had used repeated subtraction and we had said 32, how many 5s go into 32? And we say, okay, well, let's subtract 5. That's going to give me 27. Still larger than 5, so I can subtract. I'm going to get 22. Still larger than 5, so I can subtract. I'm going to get 17. 5 gives me 12. 5 gives us a difference of 7. 5, and you'll notice here it is, remainder of 2. So it went in, divided in 1, 2, 3, 4, 5, 6 times with a remainder of 2. And so we could just model what we just did and check our work that way. Okay. Now, some students might prefer looking at it as a set. So instead of using 32, I'm going to model as a set, model as a set. Instead of having to come up with 32 elements, let's change this problem to 8 divided by 3. So if I start with some set, this time I'm going to put it in a rectangle instead of an oval. And I have 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. And I want to know how many groups of 3, or when I take away, when I subtract 3, when I remove 3, when I do my repeated subtraction, and I first take out 3, and then I can take out 3 again, you'll notice I was able to take it out 2 times, and there was a remainder of 2 elements left. So this is 2 with a remainder of these 2 right here. And so therefore we could do it using sets and subtraction like we learned last week. Okay. So before, I think, let me erase this. Couple of notes I want to have you take a look at. We said that division is like undoing multiplication. They're reciprocals. So I have a question for you. I know you know this answer. What is 12 divided by 3? Well, we know the answer is 4. And I can change this into multiplication, kind of like that cross multiplying we did before. If you prefer, you can put a 1 here, but we can do a cross product. But we can see that 3 times 4 gives us our divisor. Whoops, 3 times 4 is going to be 12. So if we keep this pattern going, I know that 14 divided by 2 is 7. I can check my work by changing division into multiplication and saying 2 times 7 is 14. Well, what about 0 divided by 5? If you're not sure, think about what's going to happen. What do I need to multiply by to get an answer of 0? So 5 times what gives us 0? Well, we know that 5 times 0 gives us 0. So 0 divided by a number always gives us 0. And I'll show you something in just a moment. So following this, what about 5 divided by 0? when in doubt, work it out. When in doubt, write it out. This is the same as saying 0 times what number gives you 5? Well, can we multiply 0 by a number and get a number other than 0? No. 0 times anything is 0. So this can happen. This is called undefined. This is undefined. This cannot happen. So we call this undefined. We cannot take a number and divide by 0 and produce a number. Okay, so a way to think about this is let A be a whole number. And let's write down 3 little facts. What's any number divided by 1? Well, we get that number right back again for the same argument that I could cross multiply, and 1 times A would give me A. 0 divided by a number. Remember we said 0 divided by a number was okay. 0 divided by a number is 0. So think of it as 0 divided by a number is okay. That's all right, because we're going to get 0. But if I take a number and I tried to divide it by 0, remember we did that up here. You cannot divide by 0. That gives you an undefined answer. So no, you may not divide by 0. So a number divided by 0, a number divided by 0 is no, can't happen. That gives us undefined. So I'm going to kind of highlight that. I used to do this by just putting a box around it. And you'll find that your eyes don't need the entire box in order to create a box. So that can help. All right. So let's practice a few. Let me give you some scenarios of what we've done in the past. We've talked about the closure property of addition. We've talked about the closure property of multiplication. So is division of whole numbers closed? Let me rephrase that. I'm going to rephrase that. Sorry about that. Let's do it this way. Let's go ahead and do a little recap. Are whole numbers closed under, we're going to try all the operations we've done so far. Before we do that, always start with what you know. Always define what we know. We know whole numbers. Remember, that's the set that starts at 0 and then includes all the natural numbers after that. So those are the whole numbers we're talking about. So are whole numbers closed under addition? Meaning, if I take any 2 numbers in this set, 0 and 0, 0 and 1, 0 and 2, 2 and 5, 4 and 47, whatever your numbers are, and you add them together, will your answer still be in this set? And the answer is yes. If I take any numbers and add them to any other number in the set, I still get a number that's in that set. Now let's take a look at subtraction. If I take any 2 numbers and subtract them, will the answer be in the set? It only takes one counterexample, one time for it not to work for the entire assumption to fail. So in this case, subtraction is not closed because I can come up with a lot of examples. I'm going to start with 2 minus 5. If I take 2, which is in the set, and I take 5, which is in the set, and I subtract them, I get -3. -3 is not in the set. So that's a false statement. Since that's false, the entire assumption that it's closed is false. Whenever you end up with an answer of no or false, you must provide at least one example that to support your answer. It's impossible to show yes because this set is never ending. You would never be able to come up with every single combination. What about multiplication? Is it closed for the whole numbers? So our number's closed. So if I take any numbers that are in the set and I multiply them together, will the answer be in the set? And what about division? Division, well, let's see, I have 4 divided by 2, that's 2, it's in the set. Any of the numbers divided by 1 is in the set. What about 2 divided by 0? Well, we can't divide by 0, so that's undefined. What about 3 divided by 2? 3 divided by 2 is 1 1/2, or 1.5. Decimals, partial fractions are not in here. So therefore, division is not closed for the whole numbers. Whole numbers are not closed under division. Okay. So that's kind of refreshing what we mean by close. Now let's take a look at several examples. Let's first look at how do you show division using blocks, longs, flats, units. So let's do that. Let's use blocks, flats, longs, and units. Of course, these are base 10. That's all we've been doing so far. Here, well, I'll just put that down so you have it. Base 10. To show, let's see, 324 divided by 3 equals 108. Just want you to model that. Of course, off to the side, you can check by doing the standard that you already know. 3 goes into 300 one time. Bring this down. 3 cannot go into 2. Bring down the 4. 3 goes into 24 8 times. So that's our standard model that we grew up with. Let's model that using blocks, longs, units, flats if necessary. So 324. 324 would mean we have 4 units, we have 2 longs, and we have 3 flats. Okay. So if I draw a picture of that, or I'm going to go 3 flats. 1, 2, 3. 2 longs, each made up of 10, because we're base 10. 4 units. And if I start dividing into groups of 3, well, I look like I have 3 flats here. So that looks pretty good. That works. But I only have 2 longs, and I have more units than I need. I have 4 of them. So we're going to need to break these down all into units. Well, each of these longs represents 10 units. So because I'm running out of room, I have 3 of them right here, and I'm going to bundle these in groups of 3 whenever I can. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the first long. Then I'm going to continue and expand, break apart, borrow, regroup, rebundle. I'm going to rebundle that second long as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my 20 units for my two longs. And here are my 4 units that we have right here. 1, 2, 3, 4. And we're asking the class, we're asking the child, the student, to take this number, which now we have represented as 3 flats and 24 longs. So sorry, 24 units, and divide them into groups of 3. So you'll notice we have one group of 3 here. So we have 1 flat or 1 group of 3 flats. But notice we end up with 1, 2, 3, 4, 5, 6, 7, 8 groups of 3 units. And did we end up with any longs? No. So therefore we have 1 flat, 0 longs, 3 units. So therefore our answer is 1, 8 units. Sorry about that. So we end up with 108 as our final answer. Okay. So that's a refresher of how we look at dividing in base 10. So let's see what your students feel like by having you divide other bases so that we can take a look at why we regroup, why we rebundle or borrow. So let's look at some division in different bases. And that's how we'll probably finish this out. Okay. Well, in order to understand division, we need to make sure we understand multiplication. So here we go. Let's do this. Actually, I'm going to first say division using different bases. This helps explain the why. Why do we do it? So I'm going to start with 222 base 4 divided by 3 base 4. Well, before we can do the division, let's start by creating a multiplication table. Okay, so let's just recall a multiplication table in base 4. So if we are multiplying, and if it's base 4, we can only use the digits 0, 1, 2, and 3. So I'm going to create a table. That's what we did last section. Sorry, it's a little messy, but you get the idea. Okay. And let's look at multiplication. Well, what's really great is the first column and the first row, 0 times anything is 0. 0 times 0, 0 times 1, 0 times 2, 0 times 3. If I multiply by 1, 1 times 0 is 1, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. We haven't gotten to 4 yet, so we don't need to regroup it into the next column of longs. Now let's take a look at 2. 2 times 0 is 2, 2 times 1 is 2, 2 times 2 is 4. Well, now we have a group of 4, so I'm going to say one group of 4 with nothing left over. 2 times 3 is 6, so that's one group of 4 with 2 left over. 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 6 is bigger than 4, so we end up with one group of 4 and 2 left over. 3 times 3 is 9. 9 is definitely larger than 4. We get 2 groups of 4, which is 8, with 1 left over. So there's our multiplication chart that we can refer to. So now let's start looking at our division. If I want to take 3 base 4 and divide into 2, 2, 2 base 4, I'm going to look at my chart. 3 goes into 2, 2. Where's 2, 2? I have a 2, 1. That'll work. 3 goes into 2, 1 3 times. So this would be a 2, 1, just like we do in standard form. And I'm going to subtract. When I subtract, I have a 1, so I bring down the column, the next column, which is 2. Remember, this is base 4. 3 times what number gives me 12? 3 times 2 gives me 12. There's my 1, 2. Not really a 12, we call it 1, 2, but you can think of it as 12. 3 times 2 gives me a 1, 2, and notice we have no remainder. So we can say 200 or 222 base 4 divided by 3 base 4 gives me an answer of 32 base 4. Well, how do we check it? We check it by doing what we did with multiplication in the last section. So if I check this, I'm going to choose to use the lattice method. Use the lattice method. And I'm going to take what I think the answer is, and I know to check by the definition of division, that's the same as 3 times our quotient should give me our dividend. So if I take 3, 2, and I multiply by 3, I'm making this kind of large so that we have plenty of room, and I do the lattice method. I'm checking this by multiplying back. Switch colors here so we can see it better. Whoops, that 3 needs to move over to its own column. All right, well, 3 times 2 is 6. In base 4, remember, 3 times 2 is 6, which is 1 group of 4 with 2 left over. 1 group of 4 with 2 left over. 3 times 3 is 9. 4 goes into 9 twice with 1 left over. 3 times 3 is 9, which is 2 groups of 4 with 1 left over. And now, if you recall, with the lattice method, we add on the diagonals. So this gives me a 2. This diagonal gives me a 2. This diagonal gives me a 2. So we end up with 2, 2, 2, base 4. So it checks. So let's do it again. This time I'm going to do a base 5 just so we can practice. So which one do I want to do? Yeah, I'll do this one. All right. So let's take a look at 3, 2, 3, 2, 3, 2, base 5, divided by 4, base 5. Now, we might want to have a chart, so I'm just going to change this. I'm going to use a multiplication chart and go to base 5. Let's create a multiplication chart up to base 5. So since it's base 5, I can go out 1 more to 4. And base 5, I can use the digits 0 to 4. You also have your charts Sorry, that's a little messy. You have your charts based on what we did in class, and you should have a base 5 chart in there. But let's just good practice. So now we're looking at base 5. So I can't get anything larger than a 5. So our first row, 0 times anything is 0. 1 times anything is itself. We haven't gotten up to 5 yet. 2 times 0, 2 times 1, 2 times 2. 2 times 3 is 6. 6 is one group of 5 with 1 left over. 2 times 4 is 8. It's one group of 5 with 3 left over. 3 times 0, 3 times 1. 3 times 2 is 6. One group of 5 with 1 left over. 3 times 3 is 9. That's a one group of 5. Oh, hold on. Oh no, that's 8. 3 times 3 is 9. That's one group of 5 with 4 left over. 3 times 4 is 12. Two groups of 5 with 2 left over. 4 times 0, 4 times 1, 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. So now that we have that table, if you can pause, of course, at any time, catch up. Now let's look at our division. We want to know how many 4s will divide into 2, 3, 2 base 5. And I could have put the 5 here as well. It's just kind of crowded. So I'm going to use the inner part of my chart and go, okay, 4, 4. I'm looking for the number closest to 2, 3. Looks like 2, 2, because the next one, 3, 1 is too large. So 2, 2. And that's 4 times 3. When I subtract, I get a 1. Bring down the next number, which is a 2. Now I want to know how many 4 base 5s can go into 1, 2. Well, the smallest number without going over is a 1, 1. So let's see, 4 times, I think it's going to have to be, well, that's not a 4, that's a 3 times. So 4 times 1. So 4 times 1 is 4. And when I subtract, I end up with, well, I can't take 4 from 2. So remember, I can't take 4 from 2. So this is base 5. So I'm going to borrow. I'm going to rebundle this. And I'm borrowing 1, but I don't make it a 10 because it's base 5. So I'm borrowing 5. So this now becomes 7 minus 4. So this now is going to become 3. I'll say it again. When we borrowed or bundled or regrouped in base 5, when we borrowed that 1 long, we broke it into 5 pieces and added those 5 units to the other 2 units. And so now 7 less 4 is 3. So 4 cannot go into 3, so we're finished. So we end up with a remainder. We end up with a remainder of 3. So let's check our work. I'm going to use the lattice method again, and I'm going to check. Is 232 base 5 divided by 4, you have to have the same base, equal to 3, 1 base 5 with a remainder of 3. So let's use the lattice method. So I'm first going to check to see what happens when I multiply 4 times 3, 1. So the lattice method, I'm going to make my boxes here. This is base 5. 4 times 1, 0, 4. 4 times 3 is what we know is 12. But base 5 4 times 3, 4 times 3 is 12. That's 2 groups of 5 with 2 left over. And now if we add on the diagonals, we get a 4, 0 and 2 is 2, and 2. So right now we have 2, 2, 4, base 5. Okay. But we don't have, we forgot, that's certainly not 2, 3, 2. So this is where we need to add in our remainder. Add in the remainder of 3, and you'll notice we get 4 plus 3 is 7. But again, 7 is base 5. 7 is a 5 with 2 left over. So this 7 changes, right? We're going to end up with 2 units left, and we're going to bring one group of 5 to the next column. And now we can add 1 and 2 and get 3. Bring down the 2. And so sure enough, we end up with 2, 3, 2, base 5. So we add back in the remainder, and we have to make sure that we keep it in base 5. Okay. So we can try it one more time if you'd like. In base 7, you have that in your, I wonder if I have it with me. I do not, otherwise I would have written it down here. Let's take a look at one more problem, if you're interested. If you're not, I have put in the module a practice of division and a checklist for you to try before doing your homework. And then you can upload that into Canvas as a practice. Okay. Let's do this one. We'll have to make up our base 7. Our last example. 3, 2, 4, 3, base 7 divided by 4, base 7. So the first thing we need to do is create a multiplication chart. 0, 1, 3, 4, 5, 6. And 0, 1, 2, 0, 1, 2, 4, 6. Where's my, there it is. Too many numbers for me to try to freehand this. So I'm going to take a moment here, and while you guys are setting up, looks like I'm gonna have to rewrite all my numbers over here. I guess I could have pre-done this on another whiteboard, but it's okay. It's extra practice. Practice is always a good thing. Let's see if this is gonna work. Of course, I'm erasing some of my own lines, the whiteboard pen, but I think you have the idea. That's a 1, 2, 3, 4, 5, 6. All right, now this is multiplication. This time we're thinking about groups of 7. 7. So 0 times anything is 0. 0 times anything is 0. That one's quick. 1, 1, 2, 3, 4, 5, 6. Same thing going down. 1 times 1, 1 times 2, 3, 4, 5, 6. You don't have to do it that way. I just wanted to show you yet another way. Now I'm going to start with 2. Again, we're thinking about 7, base 7. 2 times 2 is 4. Haven't gotten to 7 yet. 2 times 3 is 6. 2 times 4 is 8. One group of 7 with 1 left over. 2 times 5 is 10. 1 7 with 3. 2 times 6 is 12. 1 7, 5 left over. 3 times 2 is 6. 3 times 3 is 9. That's a one group of 7 with 2. 3 times 4 is 12. 3 times 5 is 15. 14 and 1. 3 times 6 is 18. So that's 14, 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. So that's 2 groups, 2 left over. 4 times 5 is 20. 2 groups of 7 and 6 left over. 4 times 6 is 24. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 7 goes into 34 times, which is 28 with 2 left over. 6 times 2 is 12. It's one group of 7 with 5 left over. 18. 2 groups of 7 with 4 left over. 20. 2 groups of 7. Whoops. 6 times 4 is 24. I'm sorry. 6 times 4 is 24. That's 3 groups of 7 with 3 left over. 6 times 5 is 30. 4 groups of 7 with 2 left over. Because if you notice, they should go. Did I make a mistake here? Okay. And then 6 times 6 is 36, which is 5 groups of 7 with 1 left over. Okay. I think I've got it. Did it rather rapidly. Don't have that one written down here. So let's practice. We are now dividing 4 base 7 into 3, 2, 4, 3 base 7. So 4, let's see, 4 into 3, 2. Well, 4 goes to 3, 3, too big, so it's got to be 2, 6. 4 times 5. So that's 4 times 5 gives me a 2, 6. Now I cannot reduce, wrong word, cannot subtract 6 from 2. So I have to borrow 7 from the next column. So if I borrow 7, that now gives me 9. 7 and 2 is 9. 9 minus 6 is 3. 2 minus 2 is gone. Bring down the next column of 4. Start over. 4 base 7. 4 times what gives me 3, 4. 4. Here's a 3, 3. 4 times 6 gives me 3, 3. So 4 times 6 in this column gives me a 3, 3. Subtract. Bring down the next column. 4 times what gives me a 1, 3. 4. Well, here's 1, 5, too big. Got to back up. 4 times 2 is 1, 1. Subtract. Looks like we have a remainder of 2. So I have a remainder of 2. I can always check my work. That's what's great about this. If I check this using the lattice method, I'm saying that 4 times 5, 6, 2 base 7. So 5, 6, 2 times 4. These are both base 7. Lattice, lattice. 2 times 4 is 8, but this is base 7. 2 times 4 is 8, so that's a 1, 1. 6 times 4, 6 times 4, we know to be 24, so that's 3 groups of 7 with 3 left over. And 5 times 4 is a 2 with a 6 left over, because 5 times 4 is 20, so that would be 2 groups of 7, which is 14, and 6 left over. Uh-oh, now this one's tripping. Sorry about that. So if I go diagonally, get rid of that blob for you if I can. If I look at it diagonally, I end up with 1, 4, 5, 2, 2, 5, 4, 1, base 7. That is not what we started with, but remember we have a remainder. Plus our 2, which was our remainder. 1 and 2 is 3. Three, 2, 4, 1, 3, 2, 4, 1. You're gonna make my mistake. 1, 1, 3, 3, 2, 6. Made a mistake right here. 5 times 4. Oh, 5 times 4. Oh, yeah. Is 20, which is 2 groups of 4 with 6. There it is. Sorry about that. So now, when I add this diagonally 1, 4, that's a 9, but base 7 is a 9, which is base 7. So I'm going to have 2 left over, and I have to carry the 1. So that gives me a 3. So now I have 3, 2, 4, 1. There we go. And now when I check my work, because when I check it, it should work. So I made a mistake, not on purpose. Now when I add, I get 3. When I add, I get 4. When I add, I get 2. And remember, that was a 3. I apologize, you guys. And so here it worked, all because I made one little error over here. That's why we check our work. I knew what the answer was supposed to be, so I was able to go back and see where I made my arithmetic error. And so there you go. So I'm giving you a handout. It's going to be in Canvas for practice, and then you can check your answers. And they should all work. And there we go. And that's the end of chapter 3. All right, have a great afternoon or evening.